Hey everyone, and welcome to today's Explainer. I am honestly so thrilled to guide you through this one. Today, we're unpacking a really fascinating dynamic that's playing out inside modern organizations, how we use artificial intelligence to track human skills, and in turn, how we absolutely must use human oversight to govern that artificial intelligence. It's this beautiful, intricate dance between humans and machines, and we've got some incredible research and real-world dashboards to show you exactly how it's done. So here's our roadmap for today. We're going to start by looking at the new skills economy, then see how companies are visualizing complex data, and tackle this thing called the AI trust deficit. After that, we'll explore the three-pillar model, and finally, the path to autonomy. There's a profound symmetry here between human and machine learning, so let's get right into it.
Section 1. The New Skills Economy. Okay, let's dive into this. We really need to start by wrapping our heads around the sheer scale of the disruption happening in the modern workforce right now. The ground is moving fast beneath our feet.
Just look at this striking statistic from Coursera, 42%. That is the percentage of core job skills required today that are predicted to change substantially by 2022. Not just slightly adjust, but change completely. To put that into perspective, equipping employees with critical new skills isn't just some run-of-the-mill HR initiative anymore. CEOs globally are actually viewing it as a top 3 business threat. Basically, if you can't transform your talent, you simply can't compete. So, what exactly are those changing skills? Well, companies are in an absolute race right now to acquire and reskill their people in high-demand tech areas. We're talking data analytics, generative AI, which is everywhere, obviously, Python, cybersecurity, and project management. But, moving from just knowing what skills you need to actually assessing them, that requires a real strategy. Organizations are turning to structured frameworks for this. For instance, by using tools like ConsultPort's skills gap analysis templates, transformation managers can standardize their assessments, map out current competencies, and pinpoint exactly where those critical capabilities are missing. Because you got to know where your gaps are before you can actually fill them, right? All right, moving on to Section 2, visualizing complex data. Because honestly, how do you actually track all this learning and upskilling across thousands of employees?
You definitely can't just rely on a basic spreadsheet anymore. Today, companies rely on highly complex, data-driven dashboards. Take Coursera, for example. They approach this problem with some incredibly advanced skills development dashboards. They aren't just, logging completed videos. They actually use an AI-powered skills graph layered with a variant of the ELO chess algorithm. Think about that for a second. In chess, your ELO rating goes up or down based on who you beat or lose to. Well, Coursera kind of treats learners taking assessments as competitors in a match. Pass the test, and your proficiency estimate bumps up. Fail, and it adjusts down. This lets learning and development leaders visualize exact learner proficiency, track the average hours to mastery, and map skill development over time with, honestly, mathematical precision. Now, contrast this with how strictly we track physical infrastructure. Kevin Moore's storage utilization dashboard tracks hard drive capacities using an incredibly rigorous, formula-only foundation. It utilizes a 57-check, 2-tier validation system. It enforces strict data units, and it requires independent source accuracy reconciliation just to achieve a perfect 100 out of 100 quality score. The thing is, we track servers with absolutely zero tolerance for ambiguity. But tracking human skills with AI? Well, that introduces a very human problem. Which brings us to Section 3, the AI trust deficit. This is really the central conflict of today's explainer. What happens when users simply do not trust the artificial intelligence powering these advanced dashboards? Look at this critical insight from UX researcher Justin Nathaniel. His team was building an AI-powered skills insight report to map out workforce capabilities. The AI was looking at workplace data signals, things like job titles and software usage, to infer who actually had what skills. And technically speaking, the AI inferences were highly accurate, but during usability testing, they hit a massive wall. Participants completely rejected the data. They didn't trust the skill distribution visualizations at all, because the AI felt like this mysterious black box. Users just assumed the data was flawed, even when it totally wasn't. So the crucial point here is this. Opaque AI inference logic creates a massive trust gap. Let's be real, it doesn't matter if your AI model is perfectly accurate. If users don't understand how the AI arrived at its conclusion, if they don't know the difference between a confirmed skill and an inferred skill, they're going to default to skepticism every single time. We literally cannot deploy advanced AI systems if the humans using them flat out refuse to trust the output. And that brings us to Section 4, the three-pillar model. To solve this trust gap, we really have to rethink how we design these systems. We can look to a fantastic framework proposed by researchers at Stanford University for overcoming this deficit and building safe, trustworthy AI agents. They propose the three-pillar model, which basically acts as the bedrock for integrating safe AI agents into enterprise workflows. Pillar 1 is transparency, which ensures absolute visibility into how an agent operates. Pillar 2 is accountability, providing clear mechanisms to attribute and explain decisions so we know exactly who or what is responsible. And Pillar 3 is trustworthiness, which is all about building confidence through well-timed human collaboration and oversight. You see, you can't just program trust into a machine. You have to actively engineer an environment where trust can grow organically. And this brilliantly illustrates what that looks like in practice. Looking at the agent state transition diagram, you can see that transparency has to be actively built into every single stage of an AI agent's lifecycle, right from the moment a human initiates the agent by setting its context and goals, to its active state where it logs literally every action in an activity journal, all the way to its finished state, or even a potential abort state. If the agent hits a point of ambiguity, it pauses. It waits for a human-in-the-loop callback. Every single transition is recorded, meaning there is never, ever a black box moment. Let's actually look at how accountability and trustworthiness manifest in a real user interface. Consider a group email agent designed to draft internal communications. Before that email goes out, a human absolutely must review the AI's proposed action. The human can click approve, reject, or crucially, modify. Actually, that last one is huge, giving the AI explicit feedback, like, hey, change the event date to October 31st, or change the time. This human-in-the-loop interaction ensures the AI's actions strictly align with human intent, and it documents exactly who made the final call. All right, let's move to our final section, Section 5, the path to autonomy. We've established that strict human governance is required to build trust, right? Well, this oversight is exactly what enables the gradual evolution to fully autonomous AI. The researchers draw a really powerful analogy here, looking at the evolution of autonomous driving. I mean, self-driving cars didn't just magically appear overnight. We started with adaptive cruise control, where you had to keep your hands on the wheel and your eyes on the road at all times. Slowly, as sensors and algorithms proved their reliability through millions of miles of testing, humans were allowed to take their hands off and eventually their eyes off. Autonomy was earned, step by patient step. The progression of AI agents in the workplace has to follow this exact same path. Let's move to the next slide and see how this builds across 4 evolutionary stages. Stage 1 is assisted agents. Here, the human makes all the decisions and the AI just supports. Stage 2 is collaborative agents, where humans and AI share responsibility, kind of combining human context with machine scalability. Then we have Stage 3, supervised autonomy. The AI operates independently in constrained environments, but remains strictly accountable through human review. And finally, we reach Stage 4, full autonomy, with human governance. The AI functions independently, but always within transparent, auditable frameworks. Just like the self-driving car, full autonomy is a destination that's only reached through demonstrated safety. Ultimately, what we're looking at here is a profound philosophical shift. For a really long time, we've thought of the human in the loop as just a human whose job is to fix the AI when it breaks. That's essentially human-assisted AI. But by embracing these pillars of transparency and accountability, we're moving toward a future of AI-assisted humanity. We aren't building these tools to replace our judgment. We're building them to collaborate with us, augment our capabilities, and ultimately free us up to do our absolute best work. So, I want to leave you with this final thought to ponder as you look at your own teams and workflows. Is your organization ready for the shift from human-assisted AI to AI-assisted humanity? Are you actively building the transparency and the trust required to earn true autonomy? It's a massive challenge for sure, but as we've seen today, the roadmap is clear. Thank you so much for joining me for this explainer. Keep learning, keep asking great questions, and I will see you next time.